One single wrong amino acid. That's all it takes to turn a vital enzyme into a toxic clump of junk. To prevent this, your cells have a zero-error policy called double proofreading. It's not just a quick glance. It's a two-stage interrogation that happens before every single brick is added to the protein chain. Level 1 happens at the tRNA synthetase, the loader. The enzyme has two pockets, a synthesis site and an editing site. First, the synthesis site rejects anything too big. But what about amino acids that are too small or almost identical? That's where the editing site comes in. If the wrong amino acid slips in, it is physically forced into the editing pocket and chemically guillotined off. It's a molecular sieve that filters for chemical perfection. Even if the loader fails, level 2 is waiting at the ribosome. This is kinetic proofreading. When a tRNA enters the ribosome, it's bound to a security guard called EF2. The ribosome doesn't just accept the tRNA. It forces a delay. It waits for the GTP on EF2 to hydrolyze. During this lag time, a correct tRNA stays bound tightly. But an incorrect one? It's a weak match. The delay gives the wrong tRNA enough time to vibrate and fall off before it can ever be added to the chain. The cell uses time to filter for truth. Why this double check? Because the cost of starting over is much lower than the cost of a broken protein. The cell sacrifices a small amount of speed and energy, GTP, to ensure that your proteome is 99.99% perfect. Biology isn't about guessing, it's about filtering. The logic of the sieve and the clock.